I welcome you to this lesson. I'm teacher Katimbo Richard, teaching mathematics in this class, primary 7. Now, today I've come with volume and total surface area of the solid figures. And in the previous lesson, we looked at different volumes, and we said volume is the space occupied by an object, and if that is so, volume is formed for only prisms, like the rectangular prism known as a cuboid, then the square-based prism called a tube, the circular prism or the circle-based prism called a cylinder, the triangular prism, a trapezoidal prism, and probably a cone. So we can then find the total surface area of the same prisms, that is total area of all the faces of that particular prism question. And when you watch this lesson, you will be able to answer all the activities from page 41 all the way to 48 of our book, that is P.7 term 3. So please follow these examples, then you'll be able to answer all those activities. And now we start with the first example, which reads, find the volume and total surface area of each figure below. Find the volume and total surface area of each figure below. So we start with this kind of prism. Like you see, this face here is a rectangle, and the base is as well rectangle. Therefore, this is a rectangular prism. If it's rectangular, then we shall find the volume first, because we get the base area, which is a rectangle, which is length times width times height. I say length times width, so which is the base area, then times height. So that you have got base area times height, and the base being rectangular, we say length times width, before multiplied by the height. So volume of this rectangular prism is equal to length times width times height. Then volume equals 5 decimeters times 2 decimeters times 4 decimeters. Then we associate here for easy multiplication, where 5 times 2 is 10, and decimeter squared. That's why I've got 10 decimeters squared. Then later times 4 decimeters. So where 10 times 4 get 40, and decimeter squared times decimeter get decimeter cubed. So the volume of this cuboidal box, or cuboidal tank, is 40 decimeters cubed. As we look at its total surface area for the question, asks us to do two things: one, volume, and total surface area. Later, total area of the surfaces. It has got 6 faces for which we are going to find the surface area, the area of all the 6 faces. And now we design the formula like the room in which you are watching. That is if it has got a ceiling, and that is if it is of the rectangular shape. So it's rectangular, it is shaped like a cuboid. So assume you have entered a box that's rectangular. Assume you have got a box that's rectangular, or you are in a room and you have entered the room. Entered your room, and now you are watching, and they assume you are in a box. Now that ceiling is like the cover of that box, and the floor is like that bottom of that box. So it has got 2 surfaces of length by width. That's why we've got 2 into length times width. Then this side and this side is of length and height. The other side also for that wall of that room is length by width. So I've got two surfaces that are equal so of length and height. So plus 2 into length times height. Then I'm left with the other wall and this wall. This wall, the whole wall, is of width by height. So is the other one as opposed to it. So there are two walls of width by height. So plus 2 into width times height. Thereby designing the total surface area formula, that is 2 into length times width plus 2 into length times height plus 2 into width times height. The first thing you do is to identify the measures. How long is the length? You say length is of 5 decimeters. My width is going to be of 2 decimeters. To help you substitute accordingly, finally my height, wherever you see that edge, I'm going to put that 4 decimeter length. So that wherever you see L, write 5, wherever you see W, write 2 decimeters, and H, you write 4 decimeters. Now, substitution. So we go 2 into 5 decimeters times 2 decimeters, plus 2 into, plus 2 into length, still length times height, that is 5 decimeters times 4 decimeters, then plus 2 into, then the last one is width by height, that is 2 decimeters times 4 decimeters. In so doing, you have made your substitution easy. And now we go to the product. Now I've got 5 decimeters times 2 decimeters, we get 10 decimeters squared. Then into minutes times, so total surface area equals 2 times 10 decimeters squared plus 5. So we've got 5 times 4 is 20, so 2 times 20 decimeters squared. Then we've got 2 times 4, which is 8, so 2 times 8 decimeters squared. So then we go and get the products again. 2 times 10 you get 20, bring the decimeters squared. 2 times 20 you get 40. Still decimeters squared, 2 times 8 you get 16. Still decimeters squared. Now we add them, 24 times 16. In decimeters squared, answer in decimeters squared because it's area. 0 plus 0 plus 0 plus 6, you get 6. Then 2 plus 4 plus 1, you get 7. So the surface area of this prism is 76 decimeters squared. So that's how we find the volume and total surface area of a rectangular prism, also known as a cuboid. Now go to part B. When I look at this box here, oh, I see a triangle, so it is called a triangular prism. A triangular prism. So under the same instructions we go, find the volume and total surface area of this triangular prism. Volume. We say volume is equal to base area times height, or area of the cross section times height. But because the area of triangle, that's the formula for finding the area of the triangle, has got height. But we have two kinds of height. The next would be height is called length. So that's why we say a half times base times height times length. So volume equals a half times base times height times length, which is Radar's volume equals a half BHL. A half BHL. A half BHL. So that is a half base, height, length. So then we expand. Volume equals a half times base times height times length. Then go a half times 3 meters times 4 meters times the length of that 80 meters. So don't use this 5 because it's not base, it's not height, and it's not length. So base of the triangle, height of the triangle, then this dimension connects the two triangles. It's called a length. This is length, this is length, this is length. So it is in the shape of a triangle, that's why it's called a triangular prism. Now we cancel because we see that 4 and 2 are divisible by 2. So we say 2 by 2 once, 4 divided by 2, get a 2. So remain 3 meters times 2 meters times 8 meters, where 3 meters times 2 meters gives 6 meters squared. Then later times 8 meters to get the 30 meter here. That's why you get meters cubed, where 6 times 8 is 48. So volume equals 48 meters cubed. All in all, you must know the formula, a half BHL. A half BHL is the formula finding the volume of a triangular prism. And now, total surface area. This prism has got 5 surfaces, of which 2 are triangular. You just assume a triangular box, a box shaped like a triangle. It will be having 2 faces that are in rectangle and some in a triangle form. That's why it gets the name triangular prism, because the space inside is like a triangle. So therefore, 2 triangular faces, this one and that one, and 3 rectangular faces. The front rectangle, this rectangle, see, then the hind rectangle, this rectangle, then the bottom rectangle, that one you see the base. So it has got 3 rectangular faces and 2 triangular faces to make a total of 5 faces. Now you must note that the triangular faces are equal, but the rectangular faces differ. So total surface area will be area of the 2 triangular faces plus area of each of the 3 rectangular faces. Now we start identifying them properly. So total surface area equals 2 triangular faces. Each has got a base of 3 and a height. So these are the height of 4 meters. So this is a 3 meters, 3 meter whatever. It is a 3 meter base, and here it is a 4 meter kind of height. Why? Because of the hind width. So this is the width for the hind rectangle and the width. So the width of the rectangle are equal. So now transfer and see. Now, so that's why you say 2 triangles, each with the base of 3 meters and perimeter height of 4 meters. Now, plus the bottom rectangular face is 8 meters by 3 meters. You must note this is also 8 meters. You write that 8 properly. That's 8 meters. So it is 8 by 3. 8 by 3. So that's 8 by 3. Then, having looked at the base, then look at the front rectangular face. So the front rectangular face is 8 by 5. You must note that this is also 5 meters, and this being the length again is also 8 meters. You will then see it is 8 in length and 5 meters wide. So that's 8 by 5. Then the last rectangular face we have is the hind face, the rectangular face, that is 8 by 4. The hind, this rectangle I mean, that is the rectangle. So it is 8 by 4. And so doing, all the faces will have been identified in terms of their lengths or measures. Then the task ahead of you is to form the formula. It's very easy. 2 triangular faces whose areas are the same. So that's why I say area equals 2 times a half times base times perpendicular height. Then plus each area of each of the rectangular faces, each of the 3 rectangular faces. And in so doing, now that you know that area of rectangle length and width, you say plus length and width plus another length and width times length and width. And then you subtract accordingly. Now that you have identified their measures here, you say total surface area equals 2 times a half times 3 meters times 4 meters, then plus 8 meters times 3 meters, plus 8 meters times 5 meters, plus 8 meters times 4 meters. And now we do cancel, say by 2 ones, So I've got 3 meters times 4 meters, which is 12 meters squared. Now we go plus 12 meters squared, we go plus. After this, we go. That is 8 meters times 3 meters, we get 24 meters squared. Then 8 meters times 5 meters, we get 40 meters squared. Then 8 meters times 4 meters, finally we get 32 meters squared. So these are the areas you are going to total up to have that word total. Area of the surface is called total surface area. So we go 12 meters squared plus 24 meters squared plus 40 meters squared plus 32 meters squared, ensure inclusion of all. And now we start adding. First 1 meter squared for security of the units, then go for 2 plus 4 is 6 plus 0, of course 6 plus 2 get 8, then 1 plus 2 is 3, 3 plus 4 you get 7 plus 3 you get 10. So that we get total surface area of this triangular prism as 108 meters squared, or square meters if that's what you wish. As we look at part C, part C is bringing another prism where the base is a circle and now goes up. A circular prism is called a cylinder. So this is called a cylinder, like that tin you have, like that cup from which you drink is also cylindrical. So find the volume and surface area. Now volume says base area times height. So what's the shape of the base here? Okay, it's the circle, and area of the circle is pi r squared. Okay, so that's why this is pi r squared. And what's this? Height. So volume of any cylinder is pi r squared h. Base area times height. Pi r squared h is the one you have here. Remember, r means radius. Let's see whether I have got radius. So the distance from here up to here is never called radius. So this one is showing diameter, and there is no provision for diameter here because we said base area times height. So that's why we say my radius equals diameter divided by 2. Radius equals 14 decimeters divided by 2. So radius equals 7 decimeters. So we expand. Volume equals pi times radius times height. Volume equals r22 r27 as pi times r radius 7 decimeters times again 7 decimeters times the height, which is 10 decimeters. And now we cancel by 7 once. So remaining 22 times 7, then later times 10. So then put aside our 20 times 7 where 7 times 2 is 14. We put 1 where the 4 is written. Then 7 times 2 is again 14 plus 1 by 15. So we get 154. And now multiply 22 by 7. What about by 10? So 154 times 10, the 0 comes, you get 1,540 decimeters cubed, because we have got 3 kinds of decimeters here, and that is the volume in decimeters cubed. And volume of the cylinder, like we did in the lesson before, we got it by use of that formula pi r squared h. Then total surface area, total area of the surfaces. A cylinder has got 3 surfaces. This one, the down ones, a circle, and so is the upper one, and they are equal. Those 2 circles are equal, so it is having 2 circles, and this middle one, when you cut it through and flatten, when you cut, that is having removed the top and the bottom, you cut it into 2, like this one cut into 2, you will flatten and get something that is of rectangular shape. So this is the net of the cylinder, not a mosquito net, but a net of a prism is an exposure or a display of all faces that make up that prism. So they are all displayed here. It has got 2 surfaces that are circular and a rectangular face. So when we cut and open, the height becomes the width, and the distance around that circle, which is called circumference, being circular, is the length. So the length becomes the circumference and the width becomes the height. So no circumference of a circle is equal to 2 pi r and the width is h. That's why the area of the rectangular face of a cylinder is got by use of the circumference times height. 2 pi r h. 2 pi r h. Then the area of one circle you know is pi r squared. And another circle is pi r squared. So I've involved the total surface area of a cylinder. So we go, total surface area of a cylinder equals these two circular faces. So each is pi r squared and there are two. So we say 2 pi r squared. Then plus the circumference times height, that's 2 pi r h. Ensure here don't put squared, it's about circumference. Here put squared, it is the area. So circumference is the length, then the width is the height. So length times width, which is 2 pi r h. So the surface area of the cylinder equals 2 pi r squared h. And now we see what's our radius, because r means radius, it is 7 decimeters. Then the height is 10. The pi is greater than 7 because we have involvement of multiples of 7. So we expand. That is 2 times pi times r plus, in brackets, 2 times pi times r times h. Substitute accordingly to the surface area equals 2 times 7 times the radius, 7 decimeters times 7 decimeters again, plus 2 times 7, that is the pi, times the radius, which is 7 decimeters, times the height of 10 decimeters there. Then, task ahead of us is to cancel if and we can. But again, we can. We've got a 7 and 7 that can cancel by 7 still. So, we cancel. We'll divide by 7 once, by 7 get 1 decimeter there. And now, go down here and do cancel by 7 once. See, by 7 once, then multiply arithmetically. So, we've got 2 times 22. So we have got 44. 44 times 7 is the one we have here in the side work. 7 times 4 is 28. Write 8, regroup 2. 7 times 4 again, 28 plus 2. Regroup to get 30. So 44 times 7 gets 308. So it's the one here, 308 decimeters squared. And then you go down here. So we've got 2 times 22. You get 44 times 10. You get 440 decimeters squared. You add those two here, and to be secure, write them vertically for proper placement of the place values. So 8 plus 0 is 8, 0 plus 4 is a 4, and 3 plus 4 is a 7. So the surface area of this cylinder is 748. Please maintain the units, decimeters squared, and that is it about the volume of the surface area of the cylinder. As we look at another prism, remember I said I'm giving examples to the many figures you have, many prisms you have, which will definitely be one of these. Look at the example and then you'll be able to answer. The activities for the same pages of 41 on the way to 48. And now look at this other prism. This prism has these kind of markings. Yeah, it's marked. These show that all edges are equal. So a prism has got all edges are equal, is called a tube. It's the square prism. It's called a tube. A tube is formed the volume for like this. We say volume equals side cubed, or side times side, because each edge is equal to the other. So that if this edge is 15, this is 15, this is 15, this is 15. So all the 12 edges have got 15 decimeters there. So we go, volume equals side times side, volume is got 15 decimeters times 15 decimeters. Then times another 15 decimeters. First multiply 15 by 15, the side back here, where 5 times 5 is 25, right? 5 root 2. 5 times 1 plus 2 gets 7. And then you go 1 times 5 and 1 times 1, you get 15. You add here 5, 12, and you put 1, you get 2 and 225. So 15 times 5, 15, you get 225. But you have another 15 to be multiplied. You go 225 times 15. 5 times 5 is 25. Right, 5 we group 2, 5 times 2 is 10, plus 2 we grouped we have that 12, write 2, regroup 1. Then we've got 5 times 2. Again, we've got a 10 plus 1, get 11. So that is 1,125. Then multiply 225 by 1, you get back 225 and add. Here 5, here 2 plus 5 is 7, 1 plus 2 is 3, and 1 plus 2 is 3. So 225 times 15, you get 3,375, and that will be the volume of that tube, the square-based prism. That's 3,375 decimeters cubed. Remember, cubic units for volume and square units for area. Now, find the surface area of a tube, which is a square-based prism. You must know, like a cuboid, a tube has got 6 faces. All that for a tube, all are equal. They are square faces. So you know area of one square is side squared, or side times side. But now there are 60 squares. So go to the surface area equals 60 side squared. Then go to the surface area equals 6 times side, that's side squared. Then each side measure 15 decimeters, whenever you see S, write 15 decimeters. So that is 6 times 15 decimeters times 15 decimeters. Whereas you have already multiplied 15 by 15 here and got 225. So 15 decimeters times 15 decimeters is 225 decimeters squared. That's the area of each face. Remember there are 6, so you multiply by 6 and then do multiply accurately here in the side work. 225 times 6, where 6 times 5 is 30. Write 0 root 3. 6 times 2, you must get that 12. Plus 3, you get 5. 15 actually. Write 5 root 1. 6 times 2 again is 12 plus 1 with 13. So 225 times 6 you get 1,350, which is the answer. So you go total surface area equals 1,350 decimeters squared, and that's all about the total surface area and volume of the said tube. As we look at the last example here, so find this number 2. Oh, that has been number 1. Now number 2, find the volume of the figure below. The figure is looked at. Look at it keenly and see the space. Like which shape is that space inside? Oh. When you look at it properly from a distance, you will know this is shaped like a trapezium. Oh, the space inside is trapezoidal. So this is called a trapezoidal prism. It's called a trapezoidal prism. A trapezoidal prism. So trapezoidal. Others write zoido, others change I to go this way. So both are correct. Ziodo, zoido, so trapezoidal prism. It's like a trapezium. And now, if it's like a trapezium, then we can formulate the area. Since we said the shape of the prism determines the volume formula. Because think about the area or the formula for finding the area of a trapezium. A half of h into a plus b. Oh, and we say that the volume of any prism is either base area and height or area of the cross section times length or times height. Now, if area has got a height, like this one has got a height, the other would be height become the length. That's why volume equals a half times h into a plus b times length times l. This is l, so times length. A half of h into a plus b l, or times length. Then you start your substitution. A half of the perpendicular height, this is the one as height. So a half times 15 centimeters into the shoulder parallel side is 7 centimeters plus the longer parallel side of the trapezium, which is 9 centimeters, then times this part that joins the two trapezia, or the two trapezoidal faces, and then it is 15 centimeters as well. And now start to cancel if you can, you cannot. So first get the sum of 7 and 9, which is 16. So then write a half times 15 centimeters times 16 centimeters, then times 15 centimeters. Now 16 and 2 has provided a platform for us to divide by 2. So we solve by 2 once. Divide 16 by 2 and get 8. So of course 15 centimeters times 8 centimeters times 15. Whereas 15 times 15 is already got here as 225. So we already multiply 225 by 8. This 15 times 15 is already 225, then times 8. So 8 times 5. Good. Right? Wow. You say 40. So write 0, you put 4. 8 times 2 is 16 plus 4, you get 20. Write 0, you put 2. And then 8 times 2. You get 16 again plus 2, you get 18. Such that 225 times 8, you get that you got 1,800. So the answer is 1,800 centimeters cubed. And in so doing, you will have answered all activities if you did understand there. And whoever didn't understand somewhere, please can reach this very teacher Katimo on these two numbers 0776 2516 55. I said 0776 2516 55. All 075 72 33 066. Teacher Katimo has taught you that much. Then I wish you well in answering those activities from page 41 to 48 of our book tab 3, primary 7, and you will enjoy your being a candidate this very year. And I urge you to stay safe, for COVID-19 is real and it's deadly. Please stay safe and bye-bye.